Hi everybody. In this section we are going to see about correlation and how to frame hypothesis by using R value. How to use hypothesis that we are going to discuss today. Okay. So the correlation is we are going to find out is there is any relationship between two variables. Okay. The degree of association between two variables is called correlation. Okay. The degree of association between two variables. If one variable increase, other variable also increase. So that is called a highly positively correlated. If one variable is increased, the other variable if it is decreased, then it is called negatively correlated. Okay. Sometimes we will get R value is 0. It means there is no correlation between two variables. Okay, these are the types of correlation: positive correlation, negative correlation, and no correlation. Okay, so it is a measure of strength of association among and between variables. So we are going to find out the strength of variables which is associated between each other. So that we are going to see with the help of example. So I have taken sales value and have taken profit value. Okay, and for past 6 month data have taken. This is an example. So n is equal to 6. So n is equal to 6 in the sense you can take any 6 years data you can take, or you can take 6 month data. Okay, take the data. So to make simple, have taken only one digit number. Okay, after collecting that variable, two variable, then multiply this two variable x, y, and then x squared we have to do one column and y squared we have to do one column. Add x variable and put it here, add y variable and put it here. Similarly, add this x and y, add this x squared, add this y squared value, and take this value, substitute in this formula. Okay, this is to calculate R value. R is equal to n into summation of xy minus summation of x and summation of y divided by whole root of n into summation x squared minus summation x the whole squared into n into summation y squared minus summation y the whole squared. Okay, substitute this value here. Okay, and find out R value. Say for example you are getting approximately R is 0.94. Okay, it means what? We got positive value, isn't it? It means there is a correlation between two variable and highly correlated. It is 0.94, positively highly correlated. So there is a correlation between this x variable sales and profit variable, highly correlated. It means if x increase and y is also increase. Yeah. Okay, so that with the help of this data we can interpret there is a positively highly correlated between x and y variable. Okay, so this R is a sample. We took from the population, we took sample 6. Okay, n is equal to 6 we took, 6 data we took. For that sample we got 0.94. So the R is a correlation coefficient of sample. Okay, so where you took this sample, we have taken from the population, isn't it? The population is denoted by rho. Isn't it? Population is denoted by rho. This is not P, this is rho. RHO, rho. Okay, it means the correlation coefficient of population. Rho is correlation coefficient of population. Now we are going to set our null hypothesis. By using this R value, we are going to find out whether there is a significant relationship between two variables or not. Okay, set null hypothesis. Since we have taken from population, so take rho is equal to 0. It means the variables are uncorrelated. It means there is no significant relationship between two variables. So always null hypothesis you have to set in negative terms. Okay, so uncorrelated, it means there is no significant relationship between two variables. Your alternative hypothesis says that there is a relationship between two variables. That's why we took rho is not equal to 0. Not equal to in the sense what? Maybe the rho is less than 0 or rho may be greater than 0. So we are using two sign. So that's why we have to take two-tailed test. Okay, so the alternative hypothesis is the variables are correlated. It means it is significant. Both are significant. Both the variables are significant. So first we have to set your null hypothesis and alternative hypothesis. After finishing this null hypothesis and after setting this null hypothesis, we have to set our significant level. Our significant level is denoted by alpha. So alpha I am going to take 5%. Either you can take 5% or 2% or you can take 1% level of significant also. Okay. It tells the confident level. It tells the confidence. Say if I take 5%, it means you are 95% confident to accept your null hypothesis. Okay. So this is a significant level. So I am going to take 5%. It means I am going to check how much I have confidence to accept our null hypothesis. So my null hypothesis is rho is equal to 0. Okay, if I accept my null hypothesis, it says I am 95% confident to accept my null hypothesis. If you take 2%, it means you are 98% confident. If you take 1%, it means you are 99% confident to accept your null hypothesis. Say now alpha is equal to 5%, isn't it? 5% in the sense what? 0.05. Okay. Divide this 5% level of significance by 2 because we are going to take two-tailed test. So alpha by 2, so you will get 0.025. Okay. Since our distribution, our data we have taken from normally distributed data. So draw a bell-shaped curve. Okay, and take this side is 0.025 because we have divided alpha value is 0.025. Take this side is 0.025 and this side is 0.025 and center area is your accepted region and this tail is called rejected region. Okay. Now we took 0.025 this area and this area is 0.025. If you add these two area, you will get 5% level of significance. Your accepted region is 95% level of significant. Okay, and this we are putting on limit, no, upper limit and lower limit. This point is called critical value, is otherwise called table value. Critical value is otherwise called a table value. So we are going to calculate this calculator value and table value by using formula. Okay. First we set null hypothesis, alternative hypothesis, then we set level of significant 5%, how much confident you have to accept your null hypothesis, that we set. Then we have to set our degree of freedom. Okay, so the degree of freedom, how many times it repeated, the data is repeating, that is called your degree of freedom. Say you have a sample is 6, isn't it? So 6 minus 1 if you take, you will get 5. So the 5 is your degree of freedom you have to set by using this formula. Okay, we took two variable, that's why we have to take n minus 1 we have to take. So we will get degree of freedom is 5. Okay, now test statistics. So I used population variable and sample variable, no? So I am going to use this formula. T is equal to R minus rho divided by root of 1 minus R squared and divided by n minus 2. This is whole divided. This root is applicable for this as well as this. Okay. Now we know R is equal to rho is equal to 0, isn't it? Because the population null hypothesis we set rho is equal to 0. Substitute rho is equal to 0. So after simplification you will get R is root of n minus 2 by root of n minus R squared. Okay. If you put rho is equal to 0, this n minus 2 it will come up. So you will get R into n minus 2 divided by this value, root of 1 minus R squared. Okay. Otherwise directly you can use this formula if you set rho is equal to 0. Population, because the population is large, that's why we are using R is equal to rho is equal to 0. Now substitute this R value we already calculated, no? Substitute this value and n is 6 minus 2 divided by 1 minus 0.94 the whole square. So do this calculation, you will get your calculator value is 5.53. Okay. Now this is a calculator value. We have to find out your table value. Take degree of freedom 5 in your table. Go to your table value and take your alpha is equal to 0.025. Okay. And your degree of freedom 5. The corresponding value, the corresponding row and column where you will get your table value is nothing but your critical value. This 2.571 is your table value. 5.53 is your calculator value. Okay. Now I am going to show this diagram. See, your critical region, this point, this is called your table value, isn't it? Critical value. So critical value is 2.571. This side is positive and this side is negative. Okay. And your calculator value is greater than this, no? So it falls on this side, isn't it? This tail 5.53, it falls on this area. It means you are rejecting your null hypothesis because your calculator value is greater than your table value. Okay. So now write down the conclusion. Since the table value of t-test for 5% level of significance and 5 degree of freedom for a two-tailed test is 2.571. It's nothing but your table value is 2.571, isn't it? Since your calculator value t is greater than your tabulated value, your calculator value is greater than your tabulated value, it is significant because you are rejected your null hypothesis. Here you have to accept your alternative hypothesis. There is no particular evidence or proof to accept your null hypothesis. That's why we are rejected our null hypothesis. We are accepting our alternative hypothesis. Our alternative hypothesis what? Significant. Okay. Hence null hypothesis, what we said, rho is equal to 0 is rejected at 5% level of significance. Okay. How to infer here? And we conclude that variables are correlated. This correlation what? Your null hypothesis, alternative hypothesis. Variables are correlated in the population. Okay. Thank you.